Thanks, Kat, for that introduction. Yeah, I'm Greg Brown, and I own OEM Lubricants here in Saskatoon. A little bit of a training package. I've heard over the years, oil is just oil. And I want to tell you that that's not necessarily the case, but I want to show you a little bit of why. So, when you're talking lubrication, you're talking about viscosity, which is basically the flow of oil. Multi-grade are fluids that have the ability to flow differently under hot and cold conditions. The multi-grades are classed by two numbers. I have up here 5W30. Well, 5W is 5 winter and 30 weight is operating. So I want you to remember that when you're talking about fluids, lubricants, the lower the number, the lighter the fluid. Okay? So a 10 weight is lighter than a 15 weight, 5 is lighter than 10, 0 is lighter than 5. So the numbers on the viscosity charts and on the data sheets of lubricants are measured at 40 degrees C and 100 degrees C, and I'll show you how that works in a bit. So 75% of engine wear happens at startup. So it has to protect, it has to flow to protect when you get when you hit the key. You need 93 RPM to get the motor started. So there has to be some lubrication in between start time and run time. So the lighter the fluid at startup, the faster you're going to get oil pressure. Okay? There's a pour point, the lowest temperature under which a fluid will pour. Zero weight synthetics are now pouring down to like minus 54 C. The technology is growing and growing, and they're getting, they flow to colder temperatures. The pumpability is the temperature that the lubricant will flow. Rule of thumb is 10 degrees Celsius warmer than the pour point. Some general terminology. The first one is maybe one of the most important, and that's API you'll hear. It's the American Petroleum Institute. And what it is an organization funded by every engine manufacturer, every reputable oil company, and excuse me, and the European Gear Association. So what the API does, it sets standards that an engine oil, or any oil, sorry, but mostly an engine oil, has to have the characteristics to reach that standard. The oil companies don't set those standards. The engine manufacturers do, and then they work with the oil companies to formulate a product that will work in their engines. Over the years, gasoline engines have, I guess, graduated specs from way back when. It would have been the original oil would have been rated SA. So every time there is a new set of specs that come out, they increase to the next level. So we're up to SP for the 2018 and newer engines. That's the latest spec that we're using. In the diesel engine, we're up to CK, but I'll back up. I want to talk a little more about diesel engines. AW, I want to make sure that everybody's aware that when we're talking hydraulic fluid, AW is not all weather. AW is anti-wear. Okay? EP and EP additives, they're additives to oil to prevent welding or seizing of metal surfaces under extreme loads. Now, the oil business is tough enough, and then my good friend at Western is selling plastic skid plates.
Westward.
Yeah. So I bring that up because EP, that's a good example of where EP is used. EP is actually a metal, and it's put in grease to actually help the two plates from touching when under load. So EP is great for a grease plate, but it's not very good for wheel bearings. So what I'm trying to get at there is one grease will not do your whole farm. It just, we can't make it work. So a good engine oil lubricates the moving parts of an engine. It cleans, it seals, it cools, and it protects against rust and corrosion. There's a lot of things happening when the oil is going through the engine. So, you can take a look at the percentages of additives, but mainly base oil accounts for about 75 to 85% of a liter of oil, and there's 15% of all of those additives in different formulations. So just a couple things about the temperatures that we're dealing with. You can see that by the time we get up to the piston crown, we're looking at 800 degrees Celsius. That oil has to keep a skin so that the piston doesn't touch the ring. We can't have metal on metal. That's when we have catastrophic. In the base stocks that I'm talking about, or we refer to, Group 1 is, I guess, in the refining process, it is the first step of cleaning up the crude. So Group 1, I always say, is basically the step that takes the dinosaur poop out and the dirt and all that good stuff. And it's the easiest lubricant to refine, so it's the cheapest. So it's basically a conventional solvent refining process. And because it's the easiest to use, that's where the hydraulic oil is made. It's the cheapest way to formulate an oil. So then there's a Group 2, and this is where we call hydrocracking or de-waxing. And what we do is we turn the heat up and we turn the water pressure up, and we put it through the refinery again, and that's called the hydrocracking process. Group 3 is the second stage of hydrocracking, where we increase the heat again, we increase the pressure, and now we've pretty much got all of the wax out. It can be classed as a white oil. Okay, that's how pure it is. A lot of times, Group 2 and Group 3 are mixed together to make a multi-grade oil. Group 4 is synthetic. It is a man-made molecule out of hydrogen. Group 4 is now pretty much the standard in engine oils, gear oils in automotive, gear oils in heavy truck. And Group 5 is another group of synthetics, but there it's pretty specialized for industrial use. So a good oil, like I said, gets tested at the American Petroleum Institute. And if it passes, you get to use what we call the engine oil donut on your bottle. Okay? Now people also use that in that symbol. What that's done is it tells you they did not spend the money to go through the institute to get that rating. It's a little bit of a trick that some of the oil companies in the US do. This starburst that you'll see on the front of the motor, front of the bottle, means that that has extra friction modifiers for easier lubrication in the cold. In diesel engines, the biggest change here, we see C, A, B, C, D. Okay, we're going through the years. You get to 2007, and that's when CJ4 came. That's the biggest change in diesel engine specs ever. That's the year that we started worrying about the environment. That was the year that we started cleaning up the exhaust. And what was happening was, to meet that spec, you had to have additives that would actually hold soot, because instead of the black smoke coming out of the stacks on trucks, that's when you started putting the oil through into the crankcase, through the EGR, through a regen unit, and then out of the pipe. So we were losing all that smoke. What we did was load the engine oil with more impurities that it had to hold during its life. So in 2007, when that spec came out, there was far more R&D done, research and development, than any other lube at any other time. I was with Esso when this came out, and Esso and Cummins were the leaders in the testing. And Cummins burnt down 2 trucks with the regen, and Imperial Oil failed the CJ4 test 3 times, and it was like $840,000 per test. So the price of oil went up in 2007 because of all the research that had to be done. I mean, people had to get their money back. So today we are up to CK4, and that's just another spec for the newer engines. But what we can do here, if you have an engine that still requires CE oil, CK4 will work backwards. What's coming down the pipe here in the next year or 2 is a spec called FA4, which is the next generation of anti-pollution that we're going through. FA4 will not be reverse compatible with any other oil. I can see trouble coming, but that's where it's going to be. This chart here is interesting. I was talking about flow, and I was talking about multi-grade. This chart shows 50% 1540, which is conventional oil. The red line is 1540. The blue line is 040. What I'm going to tell you here right now is 040 is thick enough to run in the summertime in a heavy vehicle all year round. It doesn't matter. Everybody thinks, a lot of people think that 040 is too light to run in the summertime. So this chart is a scientific chart measured at the API, and it's showing that at, I think it's -10, the centistokes of the 1540 oil are around 50,000, and 0 is 10,000, so smaller number, lighter oil. Okay? So as we move across the chart, we're still at the 40-degree test point, 040, still thinner, okay? But what's happening at 100-degree or operating temperature, the zero weight oil is actually getting thicker than the conventional. Here's why. Conventional oil, I want you to think like your hand. Okay, it's natural, it's different lengths, it's different thicknesses, and when this oil is going up and down in a piston, the little finger will break off. Okay, that's the oil breaking down. Okay, the man-made molecule, consider it like your fist. It's uniform, it's thicker, it will flow easier because there's nothing catching, and that is why a synthetic oil flows better at the cold and holds heat better at operating temperature. This chart is pretty busy here, but I do have them at the back. And what I'm telling you now is not only is Agri-Auto Parts buying Klondike oil at a very good price so they can pass it on to you, but it shows that our testing has been done and we are comparable to the big guys, Shell, Chevron, Petro-Canada. Shoot the next one. We did a comparison chart on 040. Ours, Mobil, Delvac, Petro-Can, and Shell. And what you want to look at is the viscosity at 40, viscosity at 100. And I like to always remind people, if you're looking into specs, look at the viscosity index as well. So let's say 040 at 40 degrees Celsius, our 040 measures 84.3 centistokes. So it's lighter than Delvac. It's a little heavier than Duron, and Shell is the lightest at 40 degrees. When it warms up to operating temperature, the measurements are closer there. But take a look at the viscosity index. The viscosity index at the Institute, the higher the number, the better the lubricant can handle heat. Okay? So our viscosity index is measured at 185, the highest of the oils that we're comparing. That also relates to the pour point. Klondike pour point of 040 is -51. So if we say -51 pour, it'll crank to -41, rule of thumb. And Delvac is 48, 45 for Duron, and 51 again for Rotella. Now that's interesting because Klondike does not have a refinery, we use the same base stock as Shell does for Rotella. The pour points of Rotella and Klondike are exactly the same. So it's the same base stock. We did the same thing with 1540. I won't go through all the numbers, you can look at it at the back, but universal tractor fluid, we've done the same. This time we compared John Deere, Case, and Petro-Canada. Numbers are similar to what we were doing before. Viscosity index is the highest again. And if we put the right amount of lubricant in the right place at the right time, you are backed by the Klondike Lubricants Lubricant Corporation warranty, which basically says if we bust it, we buy it. Okay? So you can easily put our fluids in any application that's correct, and you'll be fully covered by a warranty. The last thing I want to tell you before I leave is I want to bring up the word, we refer it to snake oil. If you put an additive in any lubricant, doesn't matter which company, if you put an additive in it, you've just voided the warranty. And I'll tell you right now, if a motor, a transmission, a rear end, doesn't matter what it is, if there's a catastrophic failure, the first thing that's going to be done is an oil sample. And when they put it through the sample procedure, they can tell the molecules of STP power up. That doesn't matter. The spectrograph shows. As soon as they see something that's not in their original formulation, no. So I'm just giving you that for information, not a scare tactic, but just be aware. How did we do for time?
Oh, you're good.
Oh, good.
Yeah.
Good. Thanks, guys.